So in question 20, final exam review, we have given a description here. There's an object of mass of 0.5 kilograms moving at a speed of 2.3 meters per second in a negative x direction, and then it's acted on by a force given by the graph here, and after the force is removed, it's known as moving at a speed of 1.7 meters per second in a positive x direction. What's the value of f max? So I will consider this object a cart, just for some context here. So I'll just draw a situation sort of before force is acting and after the force is released. So just draw sort of a before and after. So initially the cart is moving to the left with a speed of 2.3 meters per second, and then the cart is moving to the right with a speed of 1.7 meters per second. And so this is sort of before 0 milliseconds, and this is after 8 milliseconds. And this happens, so this large change in momentum occurs because this force is a positive force. It's variable force, but it's positive. And it's going to first cause the car to slow down to rest and then speed up to 1.7. So, since we're looking at a force time curve, this question is addressing the concepts of impulse and momentum, the impulse-momentum theorem, so that the impulse J is equal to delta P. So the impulse will be equal to the area underneath the force time curve, and then delta P will be linked to the mass of the cart and the change in its velocity. So this will be the area underneath the curve here, so 1/2 of the delta T, so 1/2 the base times the height of the triangle, is equal to the mass times delta V, which is Vf minus Vi. So the only quantity we have here is f max. That's the quantity we want. We have the time of the base, we have the mass, we have the two velocities. So f max will be equal to 2 times the mass times Vf minus Vi, all divided by delta T. So you just need to be careful with your speeds here. So you've got 2 times 0.5 kgs. Final speed is positive on a velocity, minus, you gotta include the sign here of the initial velocity of 2.3 meters per second. And that's what you need to just be super careful on. Treat the momentum as a vector. It is a vector quantity, so you have to include the directional quality of the momentum, which is to include the direction. So this is what I'm indicating here, but by a negative sign, the initial momentum is negative. And divide this by, and then just be careful with your units of the time axis. So what you'll end up here with, you put this in the calculator, it should end up with 500 newtons. So choice E is the correct answer. It's a pretty sizable force, but we have a change of momentum. This ends up being 4 times 0.5, so that's 2 kilograms meters per second. It's a change in momentum, but it occurs over a very small time interval, only 8 milliseconds, so we should have a very significant force for that change of momentum to occur. This is choice E.